Problem number 9 is a similar idea. I want to graph this function, and in order to do so, I'm going to think of it in terms of a mother function and a transformation, or in this case, two transformations. So the mother function of this is going to be y equals log base 3 of x. Notice I just ignored the transformations of minus 2 and minus 1 there. So here's the problem. You may not know what log base 3 log base 3 of x looks like, but you should know what y equals 3 to the power of x looks like, just a standard exponential function, and y equals 3 to the power of x is the inverse of y equals log base 3 to the x. Hopefully you can see the connection of 3 and 3 there, my two bases. Well, I can sketch this graph super quickly, just like I did in the last problem. 3 to the power of x, well, it's got a y-intercept of 1. 3 to the 1 is 3. 3 squared is 9. 3 to the power of negative 1 is 1/3. So my graph is going to look something like this. Now clearly I missed a couple points there drawing my line in. Hard to do on the iPad, but you get the general idea. Now remember, we're talking about inverse functions, so all I have to do to get from this exponential function back to the log function, which I am of course interested in, is to reflect these points over that line, y equals x. So to do that, swap your x and y values. Well, I found some points, so I know specifically where all of these values have to go. So if I look at my first point there, that is an x value of negative 1 and a y value of 1/3. So I'm going to swap those 2 points. I'm going to say if I had negative 1 and 1/3, that point is going to go to 1/3 comma negative 1. I'm literally swapping my values there. And I can sketch that in, and it's going to be right about there. Now my next point, my y-intercept of the exponential function is 0, 1. So that's going to go to 1, 0. I will put that in. Now I found my x-intercept. Starting to see that mirrored image already. My next point over here, x value of 1, y value of 3. That's going to change to an x value of 3 and a y value of 1. So I'm right there. And then the last point I found was an x value of 2, y value of 9. So again, that's going to swap. Instead of 2, 9, it's going to go to 9, 2, which is right here. And I can go ahead and try and draw that line in now. And again, important piece to note right here, in my inverse function, y equals 3 to the power of x, I have a horizontal asymptote right there, meaning I never cross that line. That is going to translate to a vertical asymptote right there along the y-axis where my function will not cross, meaning logs don't exist in the negative realm over here. Okay, well, I'm not done yet. All I've done so far is graph y equals log base 3 of x, and I still need to think about my two transformations. But we've done the hard part. Now we just got to think about, okay, well, what do these two transformations do? Well, that first transformation, x minus 2, that was just like the last problem. That is going to take my entire function and is going to shift it to the right 2 units. So it's going to move it 2 units to the right. Did not affect my y values at all, just moved everything to the left. Now notice that yellow line there, my vertical asymptote, moved with my function. Note that. That is important. Okay, next transformation. We are looking at this minus 1 right here. Well, hopefully you remember that if you add or subtract something at the end of your function, like minus 1 there, that is going to act upon your entire function, meaning it will result in shifting your function down 1 unit. So take this function and move it down 1. Now notice, my vertical asymptote did not change that time. It is still in the same exact spot, and I am done. This is my function. log base 3 of x minus 2 minus 1.